How can an aeroplane help us determine the depth of the ocean? In this next video, we'll find out how. The laser airborne depth sounder works by having a plane which is a certain height above the water level. This height is known. It then sends a laser pulse down to the surface of the water. Some of this laser pulse is reflected from the surface of the water back to the plane. We can then work out a time that it takes for that reflected beam to come back to the plane. Some of the beam goes through the water all the way down to the bottom, is reflected off the bottom of the water, and then goes back up to the plane. That time can be measured. So the difference between the time it took for the surface laser beam to come back to the plane and the one that went to the bottom and back, we can use that information to find out how deep the water is. We know the wavelength of the laser used, and we know the frequency of the laser. We know that the velocity of the water can be determined, and we know the time. So the distance can be found out. For these calculations, be sure to check out my LiveScribe videos. On page 19 of your Key Ideas Physics book, book number 2, there's some more in-depth information about how LADS works. Be sure to read all that. This is very important. So the laser used in the LADS system is a yttrium aluminium garnet laser doped with neodymium. This has a wavelength of 1064 nanometers. The laser used in LADS is 1 megawatt in power. This is quite a powerful laser. The reason that we have such a powerful laser used in LADS is because of these reasons. First of all, if the water is turbid, so it has floating particles in it and it's not 100% pure, which no water is 100% pure in the ocean, we're going to have some of the information, some of the light scattered. So we're going to need a powerful laser that we can actually have some of the light going through like we want it to. Another reason is that the water absorbs some of the light. If we're losing some of the light by the water absorbing it, we need to have a stronger laser in order to reach the bottom of the ocean. Once we reach the bottom though, the seabed can actually absorb some of the light as well. So we need to have it strong enough that it gets reflected from the bottom, back through the water again, and can go back up to our plane. Another reason is that the surface of the water is never perfect how we want it. So we can get some scattering of the light from the surface of the water. Lastly, because we don't want to damage the eyes of people underneath the plane, we need to have some deflectors and some diffusers inside the laser system so that the beam is not a powerful stream straight down to someone's eyes that may be below it. So with these diffusers, we lose some of the power. So we need to have a stronger laser to make up for the fact that we're diffusing it. So they're the reasons that we need to have a powerful laser in the LADS system. So the key points of this video. LADS works, or the laser airborne depth sounder, works by having a plane at a certain height above the sea level. This plane sends a laser pulse to the surface of the water. Some of this pulse is reflected back to the plane, and the time taken for this laser beam to go from the plane to the surface and back is recorded. Some of the pulses also goes through the water, hits the bottom of the ocean, and gets sent back to the plane. We can record the time that it takes for this to happen, and using the difference between the two times and some calculations, we can work out the depth of the water. For our calculations on the depth of the water, be sure to check out my LiveScribe videos. There are some important points that we need to know why we need such a powerful laser in the LADS system. Some of these include if the water is turbid, if the water is not perfectly smooth, some of the light gets absorbed by both the ocean floor and the water itself, and because we use diffusers. So that's it for this video on the LADS system.